Welcome back all of you. Today we are going to solve mathematics problem from class 10th NCERT. Okay, from chapter number first, exercise 1.1. Our question is use unit division algorithm to find the SCF. Okay, our first question is 113 and 225. This is not 113. This is 135. 135 and 225. Okay, 135 and 225. So we know about the unit division algorithm. According to it, A is equal to BQ plus R. A is equal to BQ plus R. Here putting the value of A 225 and putting the value of B 135. Okay, so 225 is equal to 135 into 1 plus R. Subtracting 225 from 135, we get 90. So the value of R is 90. Now replacing the value of A from 225. Now replacing the value of A from 225 to 135. Therefore, 135 is equal to 90 into 1 plus 45. Again, 90 is equal to 45 into 2 plus 0. Therefore, the SCF of 135 and 225 will be 45. Okay. Now the next question. Is use unit division algorithm to find the SCF of 196 and 38220. Okay, using A is equal to BQ plus R. The value of A is 38220 is equal to B 196 into Q plus R. Therefore 38220 is equal to 196 into 38220 196 into 195 plus R. Okay, the value of R will be 0. Therefore, the HCF of 38220 and 196 will be 195. Okay, the value of 196 and 38220. We are using the usual division algorithm to find the SCF, and the value of SCF we get is 195. Okay. Now using again third question to find the SCF of 867 and 225. Okay, again using the same formula, A is equal to BQ plus R. The value of A is 867, the value of B is 225, and you can use 225 into 3, 675. Okay, into 3 minus 867. This is 192. Okay, now again 225 is equal to 192 into 1 sorry, 225 into 3, 675 minus 867, this is 192. 675 192 225. Okay, so 225 into 4 900, 225 into 3 675. Okay, this is 675 minus 867, this is 192. Again 225 to 192 plus 225 minus 192, this is 33, remainder 33. Now 192 is equal to 33. 33 into 6, 198. 33 into 5, 165. Okay, minus 192, 27. Okay, now 33, 27 into 1 plus 6. Now 27, 6, 4, 24 plus 3. Now 6, 3 into 2 plus 0. So the SCF will be 52. So the SCF welcome back. Sorry, there is some mistake in this question. This is not 225, this is 255. Okay, this is not 225, this is 255. So A is equal to BQ plus R. The value of A is 867. The value of B is 255 into 3. 255 into 3, 765. Okay, plus R. Subtracting from 867, we get 102. Okay, now 255 is equal to 102 into 250, 102 into 2, 204 into 2, subtracting from 255, 204, we get 51. Okay, we get 51 remainder. Now 102 is equal to 51 into 2 plus 0. Here we get the remainder, here we get the value of remainder 0. So the HCF of 867 and 255 will be 51. Okay, we get the value of SCF in this question. Now next question is, show that any positive odd integer of the form 6 cube plus 1 or 6 cube plus 3 or 6 cube plus 5 where q is an integer. Okay, our next question is so that question number 2, so that any positive odd integer is of the form 6 cube plus 1, comma 6 cube plus 3, comma 6 cube plus 5, where q is any integer. Okay, solution. Now using Euclid division algorithm, A is equal to BQ plus R. Putting the value of B, putting the value of B is equal to 6, okay, and R, it must be less than or equal to 6. The value of R must be less than 6. Okay, so using the Euclid division algorithm, A is equal to BQ plus R, and putting the value of B is equal to 6 and R less than 6. Okay, so A is equal to 6Q plus R. So putting R is equal to 1, 2, 3, 4, 5 in equation first. This is our first equation. So we get A is equal to 6Q plus 1, A is equal to 6Q plus 2, A is equal to 6Q plus 3, A is equal to 6Q plus 4, A is equal to 6Q plus 5. Okay. A is equal to 6Q plus 5. Okay. So from here we can see we get 5 equations. This is second, this is third, this is fourth, this is fifth, and this is sixth. Okay. From all these equations, our equation which we require is this one: 6Q plus 1, 6Q plus 3, and 6Q plus 5. Okay. From here you can see A is equal to 6Q plus 1, A is equal to 6Q plus 3, and A is equal to 6Q plus 5. Okay. Here from here you can see all this number are having remainder as 1, 3, and 5. Okay. So all these three equations are not divisible by 2. All these equations are not divisible by 2. Therefore, they all represent odd integer. Okay, root. From here you can see, I am explaining once again. So that any positive odd integer is of the form 6q plus 1, 6q plus 3, 6q plus 5, where q is an integer. We using the Euclid division algorithm, a is equal to bq plus r. Putting the value of b is equal to 6 and r less than 6. So a is equal to 6q plus r. Putting the value of r 1, 2, 3, 4 and 5 in equation first. We get all these three equations, and from these equations we get 1, 2, 3, 6q plus 1, 6q plus 3, 6q plus 5 as given in the question. You can see the remainder in all these questions is 1, 3 and 5, which are not divisible by 2. Therefore, they all represent a positive odd integer. Okay, this is proved. Okay, now coming back to the third question. Coming back to the third question. Our third question is an army contingent. Our third question is an army contingent of 616 members. An army contingent of 616 members is to march behind any band of 32 members in a parade. The two groups are to march. The two groups are to march in the same number of columns. In the same number of columns. What is the maximum number of columns? What is the maximum number of columns in which they can march? In which they can march. Okay. Our question is an army contingent of 616 members is to march behind any band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? Okay. So this question can be solved very easily by using the Euclid division algorithm. Okay. Solution. Number of members is equal to 616 and number of members in the band is equal to 32. Okay. Now if the two groups have to march, in the same number of columns, then maximum number of column will be equal to SCF of 616 and 32. So A is equal to BQ plus R. This is the Euclid division algorithm. A is equal to BQ plus R. Now the value of A is 616. The value of B is 32. Therefore 32 into 19. 32 into 19 is 608. Subtracting 608, 32 into 19 608. Subtracting 608 from 616, we get 8 remainder. Okay. Now again, putting the value of A is 32 and the value of B is 4. The value of B is 8. Q is 4. The remainder is 0. 8 for the 32, 32. Remainder is 0. Okay. So the HCF of 616 and 32 will be 8. So the maximum number of column in which they can march will be 8. Okay. Now coming back to the next question. Now coming back to the next question. Question number 4. Coming back to the next question from exercise number 1, chapter real number, class 10 NCERT, exercise 1.1, question number 4. Okay. Our question is, use Euclid division algorithm to show the square of any positive integer is either of the form 3m plus 1 or for some integer m. Okay, this is our question. Okay, now we are going to solve this question. Okay, let us use the Euclid division algorithm. Okay, Euclid division algorithm. A is equal to BQ plus R, where B is equal to 3 and the value of R is greater than or equal to 0 and less than 3. So we get 3q plus r. Okay, we get A is equal to 3q plus r. Now, suppose this is one question. Now putting value of r, putting the value of r as 0, 1, 2 and 3 in equation first. Putting the value of r as 0, 1, 2, 3 in equation number first, we get A is equal to 3q plus 0, A is equal to 3q plus 1, A is equal to 3q plus 2, A is equal to 3q, sorry, only up to here. Okay, we get three equations. A is equal to 3q, A is equal to 3q plus 1, A is equal to 3q plus 2. Now, squaring both sides. Suppose this is second, this is third, and this is fourth. Squaring on both sides. Squaring on both sides, we get A square is equal to 3q square, which we get A square as 9q square. Okay, A square is equal to 9q square. Now, suppose this can be written as 3 into 3q square. Okay, so factorizing 9q square into factorizing the 9q square as 3 into 3q square. Okay, now assuming 3q square is equal to m, so we get A square. We get A square is equal to 3m. Okay, we get A square is equal to 3m. Now, using the equation number third, okay, squaring on both sides, A square is equal to 3q plus 1 ka whole square. On solving this will be 9q square plus 1 plus 3 to the 6q. Okay, rearranging the terms, 9q square plus 6q plus 1. Taking 3 out from these two terms, then this will equal to 3. 9q square plus 2q plus 1 is equal to A square. Therefore, A square, assuming 3q square plus 2q, 3q square plus 2q is equal to m. So we get A square is equal to 3m plus 1, or A square is equal to 3m plus 1. Okay. Now similarly, using the equation number 4, A is equal to 3q plus 2. Squaring both sides, then this is A square is equal to 3q plus 2 ka whole square. Solving, A square is equal to 9q square plus 4 plus 3 to the 6, 6 to the 12 q. Rearranging the terms, 9q square plus 12q plus 4. Okay. Nine q square plus 4, 3 to the 6 is 12q. Okay. Now taking now coming back, rearranging this term, 9q square plus 12q plus 3 plus 1, okay, is equal to a square. Therefore a square is equal to, taking 3 outside, this we get 3q square plus 4q, 3q square plus 4q plus 1 and plus 1. Okay, now 3q square plus 4q plus 1 is equal to m. This is our assumption. Okay, we are assuming. Putting this value in this equation, we get a square is equal to 3m plus 1. Okay, a square is equal to 3m plus 1. Okay, so from all these three equations, a is equal to 3q, a is equal to 3q, a is equal to 3q plus 1, a is equal to 3q plus 2. Okay, square, what we did, we square on both the sides, we get what? A square is equal to 3q square, a square is equal to 9q square, factorizing 3 into 3q square, assuming 3q square is equal to m. We are supposing this value is equal to m. So we get a square is equal to 3m. Yani the square of any positive integer, what we get in the form of 3m. Similarly over here, the square of any positive integer, here 3q plus 1, we get in the form of 3m plus 1. And similarly over here, the square of positive integer a is equal to 3q plus 2, we get a is equal to 3m plus 1. So this is what we have to prove. Okay, now our next question, question number 5. Use usually division algorithm. Now next question. Now next question from exercise 1.1. Okay. Our next question is use usually division algorithm. Our next question is question number 5. Use usually division algorithm. Use division algorithm to show that the cube of any positive integer is of the form 9m, 9m plus 1, 9m plus 8. Okay, so this is our question. Okay, this is our question. We have to prove using the usual division algorithm, we have to prove that the cube of any positive integer will be of the form 9m or 9m plus 1 or 9m plus 8. Okay, so solution. Let solution using Euclid equation a is equal to bq plus r. Okay, putting the value of b is 3. Putting the value of b is equal to 3 and the value of r less than the value of r greater than or equal to 0 and less than 3. So what we get? We get a is equal to 3q, a is equal to 3q plus 1, a is equal to 3q plus 2, a is equal to, sorry, up to here. We get 3 equations, okay? A is equal to 3q, a is equal to 3q plus 1 and a is equal to 3q plus 2, okay? We get 3 equations. What? We get 3 equations as a is equal to 3q, a is equal to 3q plus 1 and a is equal to 3q plus 2. Okay, we get 3 equations using this as first, second and third. Okay, now cubing both sides of equation first. We are cubing on both the sides of the equation first. Okay, so what we get? A cube is equal to 3 cube. On solving we get 27 cube. Okay, we get 27 cube. Now factorizing this as 9 into 3 cube is equal to a cube. Therefore, taking 3 cube as m. Okay, taking 3 cube as equal to m. Therefore, a cube is equal to 9m. A cube is equal to 9m. Okay, so first we proved 9m. A cube is equal to 9m. Now, second one. Taking cubing both sides of equation number 2, we get a cube is equal to 3q plus 1 का whole cube. We know the formula of a plus b का whole cube. What is that? A cube plus b cube plus 3ab bracket में a plus b. So 3 cube a cube plus b cube plus 3ab bracket a plus b. Okay, if you are going to solve this, we get 27 cube plus 1 plus 9 cube bracket 3 cube plus 1. Solving more, 27 cube plus 1, 9 3 27 cube square plus 9 cube. Okay, now rearranging these terms, we can write 27 cube plus 27 cube square three 3 is 9, 3 is 27. 27 cube plus 27 cube square plus 9 cube plus 1. Okay, now taking 9 common from here, therefore a cube is equal to 9, 27, sorry, 3 3q plus 3q square plus 9q plus 1. Okay. Now, assuming this 3q plus 3q square plus, sorry, not here, 9q plus q is equal to m. Therefore, a cube is equal to 9m plus 1. Okay. The second one is also get proved, 9m plus 1. Now, coming back to the third part. The third part is 9m plus 8. Okay. 9m plus 8. Now, a is equal to 3q plus 2. Cubing both sides, we get a cube is equal to 3q plus 2 का whole cube. Similarly, a plus b का whole cube, we can write a cube plus b cube plus 3ab bracket a plus b. We can write 27 cube plus 8, 3 3 is 9, 3 3 is 9, 9 3 is 27, 27 to the 54, 54 q square plus 3 3 is 9, 9 3 is 9, 9 to 18, or 18 to 36, 36 cube. Now rearranging terms, 27 q cube plus 54 q square plus 36 q plus 8. Okay. Now taking 9 common from these three terms, therefore 9 3 is 27 cube plus 6q square plus 4q, that goes plus 8. Now, assuming 3q plus 6q square plus 4q, assuming 3q cube plus 6q square plus 4q is equal to m. Okay, we are assuming this again. We are assuming this again. What we get? We get a cube is equal to 9m plus 8. Okay. So this is what we have to prove. Okay. This is what we have to prove. Our question was, use the unit division algorithm to show that the cube of any number is 9m, 9m plus 1 or 9m plus 8. We use the equation a is equal to b2 plus r. We use the value of b is equal to 3. R, the value of r greater than or equal to 0, less than 3. Putting the value of r, we get these three equations. Now, according to the question, we are going to cube on both the sides of the equation. We are cubing a cube is equal to 3 cube, 27 cube, factorizing 9 into 3, assuming 3 cube is m, a cube is equal to 9m, first is proof. A cube is equal to 3 cube plus 1 the whole cube, a cube plus b cube plus 3 bracket a plus b. On solving and rearranging, we get a cube is equal to 77 cube plus 27 cube square plus 9q plus 1. But taking 9 as common from these three terms, we get this, and we are assuming 3q square plus 9 is equal to m. Therefore, aq is equal to 9m plus 1. The second one is also got proved. We proved the second one also. Now, coming back to the third one, is taking a is equal to 3q plus 2. Cubing both sides, we get aq plus bq plus 3ab bracket a plus b. Now solving 77q plus 8 plus 54q square plus 56q. Taking these three terms together and taking 9 common from all them, we get 3q square plus 6q square. So 3q plus 6q square plus 4q plus 8. We are taking this as m, and we get a to is equal to 9m plus 8. Okay. So this was all about the chapter number first. Exercise number 1.1 from class 10th, chapter number real number. Okay, and in the next video we are going to discuss the problems of exercise number 1.2 from chapter number 1. Thank you very much.